Today we're in section 11.3, rotations. This will be the last transformation that we learn before our next test. So your test will be specifically over translations, reflections, and rotations. Remember, you're going to have a review section on your test from chapter 8. So just keep that in mind. All right, 11.3 rotations. We will not be graphing today. All right, we will not be graphing. Just to start off, we have some important information. You do not need to draw the figure that you see off to the side, but I do want you to write the definition of a rotation. It's a transformation in which the figure rotates around the center of rotation. So it's a turn, all right? So turn would be the key word here, just like for translate, it was slide or shift. Reflect, it was flip. And for a rotation, it's a turn. And we have kind of like a code down here that I'm going to talk about here in just a minute. But I want you to write these down, okay? These are really important. If you're rotating counterclockwise, do you know what we're talking about with clockwise and counterclockwise, like a clock? All right. So how the figure is turning, okay, will tell us how the ordered pairs are changing from the original to the new. So with a reflection, it was just basically opposites. If I reflect across X, I do the opposite of Y. With a rotation, it's not quite that simple. And before you kind of get too worried about, oh my goodness, I have to remember which one's which, I actually will give you this part. This is the only part I'll give you, but I will give it to you on a test and quiz next week. Okay, so you will have that. All right, go ahead and finish writing everything down. All right, basically how it works, the reason that counterclockwise 90 is the same thing as clockwise 270. Imagine if you had a circle and yeah, it's a figure on my iPad. I didn't draw it that perfect. Okay, in your XY axis, okay, so let's just kind of say we had an XY axis here. This one might actually be helpful for you to write in your notes. Let's say that this point right here, hold on, is like our starting point, our 0, okay? And then for each 90-degree turn, okay, it increases by 90 degrees. All right. So on the first one, if I'm going 90 degrees counterclockwise, all right, first of all, we do need to establish a full circle is 360, right? So if I were to go all the way around the circle, that's 360. So if I go counterclockwise 90, that's the same thing as going clockwise 270. That's why it's the same ordered pair combination for both. Do you see that? Okay. If I go backwards 90, it's the same thing as going frontwards or clockwise all the way around to the same exact point. All right. This is not make or break if you don't understand or can't visualize this, but basically what I'm trying to explain is why counterclockwise 90 and clockwise 270 is the same like ordered pair combination, okay? So on the flip side, if I'm going clockwise 90 degrees, if I'm trying to rotate this point clockwise 90 degrees, guess what? That's the same thing as going counterclockwise 270 degrees around the other way. Okay, so that's what we're saying here. And then 180 degrees, because I'm meeting down at the same point, either way I go, that's why it doesn't matter if it's counterclockwise or clockwise. It's the same point. Okay, and again, understanding or not understanding the circle is not necessarily make or break, but that kind of gives you an idea of why these ordered pairs match with which rotations. Okay? All right, do you have it written down?
Yes, ma'am.
Okay. All right, so I am going to show you, I'm going to show you how a figure rotates. It is not our focus for today's lesson, and I've actually removed it from your homework assignment. We are going to just place a focus on the ordered pairs. but I want to show you visually how a figure is rotating. You need what is called a center of rotation, okay? Think of a real-life object that rotates. Can you give me an example of a real-life object that would rotate? All right, not something figurative. What is it? Wheels. Wheels around an axle, right? So the axle of a car and then a wheel rotates around it. What else? On an axis. It's technically on an axis, but I'm talking about something that, you know, technically the Earth rotates around the sun.
I know the candy.
Orbits.
Oh, the candy.
What is it, Jason? Would you have one?
You know that those things in a clock, like the hand? No.
You could say maybe like a hand.
A crank?
On a crank.
Like the things on the back of the truck that are always spinning.
No, like a windmill. What about a carousel? What about a carousel? Okay. All right. So a rotation, guys, centers around basically the center of rotation, or it turns around the center of rotation. So if I'm going from the original figure, again, each 90-degree turn, and if I'm going clockwise, it moves to this position. All right, can you kind of imagine that? It's turning, okay? And if it turns again the same direction, it would be at 180 degrees. And if it turns again, now it's at 270. All right, so basically what I need you to get from this slide, you don't even necessarily have to write down the arrows, okay? It's what is happening when a figure is rotated. It's turning in 90-degree increments, okay? Either clockwise or counterclockwise. And that's what I'm doing with the ordered pairs, okay? So now this is the part that's going to be on your quiz, your test, your homework, okay? Rotating a figure using ordered pairs. I need you to write down the 4 original ordered pairs. The 4 original ordered pairs, and then we're going to talk about the code. And then on the second one, write the 3 original ordered pairs. I want you to skip like at least 2 or 3 lines in between, okay? You do not have to write the directions, okay? Just write the original ordered pairs and leave space below to write your new ordered pairs. Okay, so before we go any further, I just want to back up real quick and show you something about each one of these codes when they're grouped together. All right, what do you notice about the first set of ordered pairs on all 3 of them? What do you notice? That they're all the same. Here's what that means. That means that it's the original ordered pair. Okay, so whatever the original ordered pair, that's what XY stands for. So your original ordered pairs might be negative. They might be positive. That's basically just saying this is the original. Your second ordered pair, this is what tells you how you are going to rotate it. Okay? So the negative in the second ordered pair does not mean that Y is going to be negative. It means that Y is going to be the opposite sign of what it was in the original. Okay? So that negative sign is not make Y negative, it's make it the opposite of what it was in the original. And what else is happening to the order that you see in that first one? It's going from XY to YX. So that means that I flip the order also for counterclockwise and clockwise 90 and 270. Now for 180, we see that we keep the same order, but what's happening to my X and my Y? They're both the opposite. Okay, so that actually is one that you'll probably memorize, just even unintentionally. If you're rotating 180 degrees, whatever your XY is, now it's going to be the opposite sign in your new ordered pair. Okay, so if we understand what the code is telling us to do, we can rotate these ordered pairs without problem. All right, now, again, I'm giving you the code on your test. Okay. So this is not something that you will have to memorize, all right? So let's look at these ordered pairs. J, -4, -4, I'm rotating 180 degrees. My code says if it was X, now it's -X. What does that mean? It's the opposite sign of the original X. And same thing goes for Y. So since my original ordered pair is -4, -4, my new ordered pair is 4, 4. I just do the opposites, okay? All right, so for K, for point K, can anyone give me a shot at it? Kyle?
4, -2.
4, -2. We just do the opposite. All right. You try L and M. Just go ahead and finish it. So, Gabe, what's the next one?
1 and 0.
1 and 0. Guys, it's not +0, -0. It's just 0. What about M? Guys, just tell me, what is it? 2, 3. Okay. So, for a 180-degree turn, whatever the original ordered pair was, in the new one, I do the opposite, keep them in the same order, of X and Y. Now let's look at the next one. I'm rotating the figure 90 degrees clockwise about the origin. Now, this is not necessarily important, but I do want to mention it. 90 degrees clockwise is the same thing as what? If you met it going the other way. 270 counterclockwise, because you're meeting at the same point. So that's why the code is the same. All right, so the code tells me that I'm going to switch the order of X and Y, and which one, X or Y, is going to be the opposite sign in the new ordered pair? X. That's what the negative is saying. It's not saying it's going to be negative. It might be positive. It just means I have to do the opposite sign. Flip them and do the opposite sign. So for point A, -3, 2, that means I flip them and do the opposite of X. If X was -3 in the original, now it's +3 in the new one. Okay? I want you to try B and C. Isaiah, what's B?
1, -6.
Very good. It's 1, -6. And C, Noah, what'd you get for C?
-5, 1.
Okay, -5, 1. Any questions on the rotations? Okay, so on the next one, we see here a rotation and a reflection. This is using more than one transformation to get to basically like your final ordered pair. If you were to graph, you would graph the original figure, and then you would only graph the final ordered pairs after you rotate and reflect. Okay, so let's take it a step at a time. The first step is to rotate each of these ordered pairs 90 degrees clockwise. So I want you to go back to your code. Go back to your code and figure out, okay, if I'm going 90 degrees clockwise, what's happening to these ordered pairs? Am I switching them? Which one am I doing the opposite? Go ahead and try to fill in A, B, C, and D. Okay, just on the rotations. And then we'll check in just a sec. I'm going to walk around and check on you guys. All right, so what's going to be my first ordered pair? We do flip them, and we do the opposite of X. So it's going to be what, class?
-3, 3.
-3, 3. All right, now we flip the order and again do the opposite of X. So now it is -3, -1. -1. You still have to reverse the order. All right. What about C? What about C? Does anybody have point C? Isaiah?
1, -5.
No, not for point C. No, the new ordered pair.
Oh. -5,
-5, -1. Kennedy, do you have the last ordered pair?
Yes. -5, 3.
-5, 3. Okay, flip them and do the opposite of X. Now that you have your rotated ordered pairs, now you're going to reflect them across which axis? It says it up here in the instructions, the Y axis. So if I reflect across Y, I do the opposite of X. I don't switch the order. I didn't do any of that on my quiz yesterday. So for -3, 3, now if I'm doing the opposite of X, what's going to be my new ordered pair?
-3, -3. 3,
3, no. 3. Look, guys, take the first, what? We are reflecting the rotated ordered pair. So look, I just circled it. We're not going back to the original. We've rotated, and then we reflect it. Okay, so it's going to be 3, 3. How did I know which one to do the opposite? It's which axis I'm reflecting, which you were quizzed on yesterday. If I reflect across Y, I do the opposite of X. So what's going to be my next ordered pair? What's going to be my next ordered pair, Jason? 3 negative 1. What about my next one, Gabe?
5 and negative 1.
5 negative 1. And anybody for the last one, Ayana?
5, 3.
5, 3. Okay, so we rotate and then we take those ordered pairs and we reflect them. All right, so that's more than one transformation. Okay, here we go. Now we're going 270 degrees clockwise. This is a carousel example. It's represented in the coordinate plane. You can see it represented in your book. What we're doing basically is we're taking these 4 ordered pairs and we're rotating them according to our directions, 270 degrees clockwise. Thankfully, you have a key for 270 degrees clockwise. That would be, you start at XY, and then you flip them, and which one becomes the opposite? The Y. Okay, so now there's your key, there's your code. Now go ahead and rotate these 4 ordered pairs. Okay, so we flip it. We flip it, guys, and we do the opposite of Y. So for point A, it's now going to be, say it with me, 4 negative 4. Point B, 0 negative 3. You can't have a negative 0. Point C, 2 negative 1. And point D,
3 negative 2.
3 negative 2. Okay, so understanding the code is really the key. That's why we say, like, if you can crack the code, you can do these rotations. If you understand what the code is telling you, you will understand how to change these ordered pairs. Okay, and if you understand that, that's everything you need to know for section 11.3.